In this demo, Tannera, Phluido, and Effnet proudly present the cloud-native private 5G RAN solution. The demo shows a reference design of a pre-integrated, pre-verified, and commercial-ready solution for platform-agnostic cloud infrastructure. The demo will showcase the end-to-end functionality of a private 5G network with connected commercial UEs. Additionally, it will cover features such as scalability, flexibility, and virtualization, which are essential for multi-cell deployment. First, let's briefly describe the demo setup. The private 5G RAN solution is deployed on a general-purpose server. The server is based on an Ampere Ultra processor with ARM Neoverse N1 CPU cores and runs Ubuntu Server operating system. It is connected to Benatel's RAN 650 commercial RU via a 10 gigabits per second optical link. Commercial UEs are used for end-to-end functionality demonstration. For this demo, we use Open 5G core, Effnet's 5G Gnode BCU, and 5G Gnode B DU components, and Phluido's 5G upper layer 1 run in separate containers. Tannera's look-aside acceleration IP runs on AMD Alveo U50 FPGA acceleration card. Since fully virtualized, the accelerator can serve multiple cells, which will be presented later in the demo. Initially, we will test the basic functionality by streaming a YouTube video. We can see that the UE attaches when the airplane mode is off and that the video is successfully played. However, a YouTube stream cannot populate the available 100 MHz spectrum, so we will run iPerf to measure the achievable bandwidth between the UE and the server. For the purpose of better understanding the network behavior, we use a graphical user interface that shows some statuses and performance metrics. In the upper right corner, we can see the counter of connected UEs and the number of simultaneously running cells. On the left-hand side of the screen, we show the downlink and uplink throughput in the end-to-end cell, usage percentage of physical resource blocks, and MCS distribution in PVSCH and PUSCH. At the bottom left corner, we can see the information throughput through the PCI Express accelerator. Now, both downlink and the uplink throughput are much higher since the spectrum is better populated. With acceleration, a single server can run many cells in parallel. To demonstrate the capability for multi-cell deployments without the need for numerous radio units, we run one end-to-end cell connected to the network core in parallel with another 7 emulated cells. Emulated cells use the same physical layer software as the end-to-end cell, but it is driven by instances of TestMax software which emulates radio and upper layers. Emulated cells are also configured for downlink-centric TDD configuration, with the difference of having 4 downlink and 2 uplink layers. All components run in separate containers. The accelerator is accessed through virtual functions and shared among all 8 cells. Now when we have the end-to-end connection established, let's bring up the Docker containers with emulated cells. We can see that the aggregate throughput through the accelerator card is now much higher than before. This way, we demonstrate the full cloud-native solution that virtualizes all hardware resources and guarantees scalability. However, these numbers are way below the peak accelerator capacity. At the end, we turn off the emulated cells, stop the iPerf, and go back to airplane mode. With the cloud-native private 5G RAN solution, our joint commitment is to ensure a successful rollout of private 5G networks in a highly dynamic and competitive telecom environment. At the same time, the solution supports various industries and markets and unlocks the full potential of AI applications that are sensitive to system latency and demand high data rates. For more information, please contact us. Deploy your 5G network today.